First and foremost, greetings to all. My name is Jyotsna Tripathi from BSc third year, and I'm here to present on the topic tensor form of gradient, divergence, and curl, which is a topic from differential geometry and tensor analysis paper. Now, what is gradient of scalar? The gradient of scalar is denoted as phi and is defined as its ordinary derivative, and it is denoted by grad phi or del phi. That is, grad phi is equals to del phi, and del phi we can write it as del phi by del x I. Now, what is the divergence of a vector? Let AI be a contravariant vector. The divergence of AI is defined as the contraction of AI, j, or in the other. So the divergence of AI is defined as the contraction of AI, j, or in the other words, the contraction of covariant derivative of AI is defined as the divergence of a vector AI. The divergence of AI is denoted by div dot AI. Thus, the divergence of AI can be written as AI, I. Now, there is a theorem that if AI is a contravariant vector, then it is to prove that divergence of AI is equals to 1 upon root g del by del xi of AI root g, where g is equals to modulus of gij. Now we can prove it like by the we know that by the definition of xi, covariant derivative of AI is given by ai comma j del ai by del xi plus ap in bracket ipj pj setting, or we can say by replacing j from I, we will get uh, ai comma I del ai by del xi plus ap. Okay, now equating it becomes ai del ai by del xi plus this whole ap by ai by pi will become ap del by del xp log of root g, as it's a formula. So equating it further and replacing by dummy suffix p by I. Now replacing p by I, so finally we will get 1 upon root g in bracket del ai by del xi root g plus ai del root g by del xi. Now you know that divergence ai is equals to ai comma I, which is now equals to 1 upon root g. Now a is summed by 1 comma 2 comma n. From n values I can take from 1 to n values, so it finally becomes 1 upon root g del ai root g by del xi, which is the required proof we have to prove, so it is proved. Now, what is the curl of a vector? Let ai be a covariant vector, then we have ai is equals to del ai by del xj minus ap in bracket pij. Now, interchanging suffixes I and j, noting that pij is equals to pji, doesn't matter. So, we get aj comma I is equals to del aj by del xi minus ap pij. Now subtracting the equation 2 from the first, we will get ai comma j minus aj comma I is equals to aij del ai by del xi minus del ij by del xj. Now the tensor ai comma j minus aj comma I of rank 2 is defined as the curl of a vector ai and is denoted by the curl ai. Thus curl ai is equals to ai comma j minus aj comma I. Now there is one more theorem to prove. So theorem says to show that the covariant derivative of a covariant vector is symmetric if and only if the vector is gradient. So to prove this theorem, we have to consider the necessary condition and the sufficient condition. So for the necessary condition, let ai be a covariant vector. If covariant derivative of ai is symmetric, which means that ai comma j is equals to aj comma I. Put that in first as a first equation. Now because since the curl ai is equals to aij minus aj I is equals to 0, now this shows that if covariant derivative of ai is symmetric, then curl ai vanishes. Now we will show curl ai is equals to 0, then ai is equals to grad phi, where phi is a scalar. From the second equation, we have ai comma j minus aj comma I is equals to 0, or you can say del ai by del x j minus del a j upon del x I is equals to 0. Now equating it and replacing rearranging and multiplying it by dxj, we finally get that dai is equals to del by del xj in bracket aj dxj. Now on integrating this equation, what we find is ai integration del by del xi aj dixj, and rearranging it, we finally get ai is equals to del x del by del xi integration of aj dxj, putting it as a third equation. But this integration part is a scalar quantity. Let this scalar quantity be phi. Then from 3 we find that it becomes ai is equals to del phi by del xi, which we have to prove, that is ai is equals to grad phi. Now the sufficient condition is, if ai is equals to grad phi, then we have to prove that the covariant derivative of ai is symmetric. Now we have del phi. Del phi is equals to del phi by del xi. Since ai is equals to del phi by del xi, so by rearranging we can get that del ai by del xj is equals to minus del square phi by del xi del xj. Now interchanging I and j, we find that the equation becomes del ai by del xi is equals to del square phi upon del xj del xi is equals to del 2 phi by del xi del xj. From 4 and 5 we finally get that aij minus aj comma I is equals to 0. Hence covariant derivative of ai is symmetric. Now this is all about the curl. This is all about the tensor form of gradient, divergence and curl. Thank you so much.